Welcome to this quicker explanation of the coding of gradient descent one-to-one. So this is the code. So basically what we did here is we, when looking here at the table of weights, input, hypothesis function, target, loss, and gradient descent, this is all we have to implement. We have the weight, input, and target as variables defined at the start, and then we define the three functions as h of w and x as defined here, right? And then we return x and w. Here we have the loss, and then we return the loss. Then gradient descent is where we have the weight, input, target, and alpha as the learning rate. Then, just like in the pseudocode we had here, we have the change equal to the derivative of the loss function, which is this, right? So if you don't know why, watch the last video, the last math video, the one-to-one gradient descent, and then we apply that change. So we say weight equals so w equals w plus change. You can also return the change and then do that here. So you have weight equals weight plus gradient descent. That's just however you want to do it. And then we have what we do here is we use a for loop to iterate over. We print the loss function so that we see how well we're doing. And then we have the weight equal to the gradient descent, because that returns our w, which was changed proportionally to the derivative of the loss function. And then we have so we set weight equal to gradient descent of weight, input, target, and this is the alpha, the learning rate. What you could probably do is you could have like a default parameter like 0.01 or something. That would probably help. Now if you run this, you see that at the start you have a really high loss, and then the loss gets smaller and smaller. Right here, this e minus 5 here, or e minus whatever, means that there are that many zeros in front of this number. So this one actually is 0.00. So I mean this one is 0.00000536. That's why. So this is not getting worse. It's actually still getting better. It's just a different notation. And down here we have a gazillion zeros in front, which this one we can basically just treat as a zero. It's completely irrelevant. So yeah, so that's how we do it. The code is in the GitHub, and the GitHub links in the description. So yeah, it's pretty much it. You can play around with this alpha. So if we set the alpha too high, or what I said before, if we set to 0.1, so we get this explosion. This losses increasing by 100-fold every iteration. That's some huge number right here. Again, the e plus something, meaning there's this many zeros after it. So that's a number with a lot of zeros. Yeah, so that's basically it.